Hi guys, welcome to today's tutorial. Today we'll be looking at exponential equations and indices. Alright, now exponential equations are algebraic equations in which the unknown variables is at the index. Now we'll talk about exponential equations and indices. Alright, we've done the first part of our class on the laws of indices. Do well to check the full detailed video from our playlist. Okay, now moving on to exponential equation. The example says solve for x in 3 raised to x equals 81. And our second example is 5 raised to 2x equals 1 over 625. Now, in solving for this, alright, now for 1, we have it as 3 raised to x equals 81. Okay, now we are going to find the value of 81 in the basis of 3. Okay, we are going to look for how to equate 81 to have a number 3. And we know that 9 times 9 gives us 81. Okay, and 3 times 3 gives us 9. So if we have our first break for 81 as 9 times 9, alright, now the second break would be 3 times 3 times 3 times 3. That is to say, 81 would give us 3 raised to 4. So if we multiply 3 4 times, we will get 81. So replacing that here, 3x equals 3 raised to 4. Why? Because 3 raised to 4 gives us 81. Now, since they are now in same basis, alright, we can equate them. Alright, so therefore, our x equating our basis, this cancels out. X gives us 4. Now with this, we've solved for x in this equation. Alright, now to our second example that says 5 raised to 2x equals 1 over 625. Now, same way we did this, okay, we are going to look for a value of 5 when multiplied together to give us 625. Okay, we know that 25 times 25, 5 times 5, 25 rather than 5, carry 2. 10 plus 2, 12. This is 5 times 2, 10, rather than 0, carry 1. 4 plus 1, 5. So this gives us 625. That means our 25 times 25 will give us 625. So if 625 equals 25 times 25, that's our first break. And the second break is 5 times 5 times 5 times 5. That is to say 625 equals 5 raised to 4. Okay? Now, if 625 equals 5 raised to 4, we can now rewrite this here as 5 raised to 2x equals 1 over 5 raised to 4. Now, in our laws of indices, when we have 1 over a number, let's say we have 1 over ax, this can be rewritten as a raised to minus x. Remember our negative law of negative index law. Okay, a negative index law helps us. So rewriting this as this, we'll now have this as 5 raised to 2x equals 5 raised to minus 4. Okay, now we cannot equate our bases since they are now the same. Now equating our bases leaves us with 5 cancel 5, 2x equals minus 4. So therefore our x equals minus 4 over 2, which gives us a minus 2. So the value of x in this equation would be a minus 2. Alright, let's look at another set of questions that deals with exponential equations. Now the first question says, find the value of x in 3 brackets 2x raised to x minus 3 equals 384. Okay, and the second question says, find the value of x in if 16 raised to 3x equals 1 over 4 bracket open 32 raised power x minus 1. Alright, now in solving this, our first question, for question 1, we have 3 bracket 2 raised power 3 minus 2x minus 3 equals 384. So the first thing we are going to do here is to divide both sides by 3. So if we divide both sides by 3, this becomes 2x minus 3 equals 3 here 1, 3 into 8, 2 into 24, 8. Okay, 1 to 8. Okay, now having this as 1 to 8, we cannot break down 1 to 8 in the place of 2, and that will give us 1 to 8 being broken down will give us 2 raised power 7. Alright, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, that is 32. 32 times 2, 64, and 64 times 2 will give us 128. So we can write this to be 2x raised power x minus 3 equals 2 raised power 7. Now with this, we have equal bases, so we can equate our bases, leaving us with x minus 3 equals 7. So therefore, our x equals 7 plus 3, which gives us 10. So our x equals 10. Okay, so next, we are looking at our second question, where we have our 16 raised power 3x equals 1 over 4 bracket 32 x minus 1. Okay, now in this, alright, we are not going to divide, but we'll convert all this since we can put them in base 2. Since we can put all this in 2's, okay, where we have our 16 as 2 raised power 4, alright, and we have our 4 as 2 raised power 2, and 32 as 2 raised power 5. Okay, now replacing all this in here, we have this as 2 raised power 4 bracket 3x, okay, equals 1 over 2 raised power 2 bracket 2 raised power 5 bracket x minus 1. Okay, and we know that 2 raised power 2, 1 over 2 raised power 2, applying our index law, would be, if we have 1 over am, gives us a raised power minus n. Now applying this negative index law, here we have it as 2 raised power 4 times 3, 12x equals 2 raised power minus 2 bracket 2 raised power, this will give us 5x minus 5. Okay, now remember that this is multiplying. Okay, and in our multiplication law, multiplication of our index turns to addition. So this we have as 2 raised power 12x equals 2 raised power minus 2 plus 5x minus 5. Okay, now with this we cannot equate our bases. Equating our bases here, this will cancel this, leaving us with 12x equals minus 2 plus 5x minus 5. Okay, minus 2 minus 5 will give us 12x minus 5x equals a minus 7. 12 minus 5 will give us 7x equals minus 7. So therefore, our x equals minus 7 over 7, which gives us minus 1. So the value of x in this solution would be minus 1. Alright, if you've enjoyed our lecture so far and don't have any question, don't forget to put it down in the comment section below. Share this link with your friends if you've enjoyed this lecture so far. Alright guys, welcome back. Now, our next question says, if 2 raised power x plus 2 x minus 1 equals 48. Find the value of x. Now, in solving for this, we have it as 2 raised to power x plus 2 raised to power x minus 1 equals 48. Okay, for this, we are going to expand, open up this. Now, we know that in our law of indices, subtraction is division. So, opening up this, we have it as 2 raised to power x plus 2 raised to power x divided by 2 raised to power 1. Okay, now having done that, we can now, we know that 2 raised to power 1 is 2, so we can still leave it at that, equals 48. Okay, so we can now factorize this. Factorizing this, what's common here is 2x, open bracket, 1 plus 1 over 2, okay, equals 48. So this gives us 2x, adding this will give us 3 over 2 equals 48. Okay, so now we multiply both sides with the inverse or reciprocal of 3 over 2. So this gives us 2x times 3 over 2 times 2 over 3 equals 48 over 1 times 2 over 3. This cancels out, okay, giving us 2x equals 96 over 3. Okay, so having it as 96 over 3, we can break it down. 9 here and 2x equals 3 here, 2. Sorry, 3 here, 3. 3 here, 2. Okay, making it 32. Now, if we break 32 into basis of 2, sorry, this should be 2 raised to power x. Okay, 2 raised to power x. Sorry. Okay, this gives us 2 raised to power x equals 2 raised to power 5. Now, equating our indices, x equals 5. So with this, we found out that our x equals 5. Now, to the next one, it says if 8x squared, 8 raised to power x divided by 2 equals, we have 8 raised to power x divided by 2 equals 2 raised to power 3 over 8 times 4 raised to power 3 over 4. Okay, now we should find the value of x. Now, for us to find the value of x, let's break this down into 2. 8 will give us 2 raised to power 3 times x over 2 equals 2 raised to power 3 over 8, okay, times 2 raised to power 2 times 3 over 4. So this gives us 2 raised to power 3 x over 2 equals 2 raised to power 3 over 8 times 2 raised to power 2 here 1, this is 3 over 2. Okay, now equating our basis, we have it as 3x over 2 equals 3 over 8 plus 3 over 2. Okay, now having it like this, okay, we can now add up this and find our value. So adding this up, our LCM here will be what? 8. Having our LCM here as 8, this gives us 3x over 2 equals 8. 1, this 3 plus 2 here, 4. 4 times 3, 12. Okay, so this we have as 3x over 2 equals 15 over 8. Okay, now we can cross multiply. If we cross multiply, 3 times 8 gives us 24x equals 3 times 2, 15 times 2 gives us 30. Okay, so our x will become what? X becomes 30 over 24. Now break it down to its lowest term. Okay, 2 here. Okay, yes, 2 here will give us 15 all over 12. Okay, 3 can also go in. 3 into 15 will give us 5. And 3 into 12 will give us 4. So therefore, the value of our x becomes 5 over 4. Alright, if there's any question, don't hesitate to put it down in the comment section below. Okay, to another set of challenging questions. Remember, we are here to help you navigate solving these questions easily. Okay, now the first question says, solve the equation 4 raised to power x squared equals 64 raised to power x divided by 16. I know as a student who just find this, oh my god, how would I solve this? But not to worry, let's get through this together. Now, in solving this, we have 4 raised to power x squared equals 64 raised to power x over 16. Now we are going to break each and every of these into the powers of 2. Okay, we can still go with 4 since 64. We can get the powers of 4, 64 in 4s, okay, and 16 in 4. So for us to eliminate it quickly, we can do this as 4x squared equals 4 times 4, 64 will give us 4 raised to power 3, okay? So this gives us 4 raised to power 3x all over 16 is 4 raised to power 2, okay? Now, remember that division is subtraction. So this becomes 4 raised to power x squared equals 4 raised to power 3x minus 2. Okay, now we can now cancel out. For us to have x squared equals 3x minus 2. Okay, now we can solve this as a quadratic equation. Moving both parties here over to this other side, this becomes x squared minus 3x plus 2 equals 0. Now solving this out quadratically, let's factorize. Our factors here of 2 will be 2 and 1. So if we have x squared x squared minus 3x plus 2 equals 0, when we factor 2x squared, we are having it as 2x and x. Okay, now since it is minus, both will become minus. Okay, so because minus times minus will give us plus, minus plus minus will give us minus. So this we are having as x squared minus 2x minus x plus 2 equals 0. Now grouping these two together, here we have our x is common, and this is x minus 2. Here we have x is common, x minus 2. Okay, sorry, 1 is common, not x, sorry. Alright, now this we are having as x minus 1 equals 0, x minus 2 equals 0. So therefore, x equals 1 or x equals 2. So the two values of x in this equation could be 1 or 2. Okay, now to our second question. It says, solve the equation simultaneously. We have 2 raised to power 3x minus 2y equals 16 and 3 raised to power x plus 3y equals 243. Okay, now what we are going to do, we are going to break our 243 down in the powers of 3 and 16 down in the powers of 2. So this will give us 2 raised to power 3x minus 2y equals 2 raised to power 4. Okay, and this will give us 3 raised to power x plus 3y equals 3 raised to power 5. Okay, now having our basis in that way, we can now equate our indexes. Now, for equation 1, we have it as 3x minus 2y equals 4, equation 1. And equation 2, we have it as x plus 3y equals 5, equation 2. Okay, now we can now start solving this out simultaneously. First of all, we are going to equate either our x or our y to be equal. So in this, I am going to equate our x to be equal. So we multiply equation 2 by 3. Okay, multiply equation 2 by 3. This becomes 3x minus 2y equals 4 and 3x plus 9y equals 15. Okay, here we are going to do what? Subtract. So if we subtract, this becomes 3 minus 3. 3 minus 3 will give us 0. Alright, minus times plus will become minus. This gives us minus 11. Okay, and this will become 4 minus 15 will give us minus 11. So, this is minus 11y. Okay, 4 minus 16 will give us minus 11. So here, our y would be minus 11 divided by minus 11, which gives us 1. So the value of our y would be 1. Okay, now substituting y into our equation 1, okay, we have 3x minus 2y equals 4. Okay, y is 1, so this gives us 3x minus 2 bracket 1 equals 4. So 3x minus 2 equals 4. 3x minus equals 2 plus, 4 plus 2. Okay, 3x equals 6. So therefore, our x equals 6 divided by 3, x equals 2. So if x equals 2, x equals 2 and y equals 1. So we've solved our question out simultaneously. Okay, alright guys, with this, we've come to the end of today's tutorial. Alright, if there are any questions or comments, put them down in the comment section below. Don't forget to like, subscribe, and share this link with your friends. See you in our next class.